Remember from last year in geometry, we already did graph circles, okay? But we just graphed very basic circles that were already given to us. So a lot of this will be a repeat in the beginning, okay? But I have a feeling that it's not going to be as easy as it sounds right away. Once you do a few problems, it'll be quite simple. So the problem here we're going to be looking at is to first come up with where the equation of a circle comes from. And that's what we're going to start with. We're going to look and derive the actual equation of a circle. So to do that, let's start by simply drawing a circle centered at the origin. And you're just sketching. You're just sketching right now. So starting with a circle centered at the origin. Thank you, Vanessa. Turn that vibrate off, please. Go from the center now up to a random point on here. What do we call that? Radius. Label it R. Whenever I put stuff like paragraphs up there, you need to read it. And if you want to write it, if you don't know it, if you don't remember that already, if it's something that's new to you, then you write it. Or you write a shorthand version of it. That's up to you completely. I'm never going to tell you what you need to write in your notes. That's up to you to decide. Now, if I label this point here, x, comma, y, what does that mean about the location of the point, x, comma, y? What does that tell me? And it's a very basic question, even though it sounds a little bit complicated, but what does x, comma, y mean? Good, John, say it. So say it as you do that. As I go over how far, and I go up y, right? Think about what he's saying right now. I know it's very basic, but you go over x and you go up y. So do this now. Put a little dashed line to here, and a dashed line up here. Call that x, call that y. Because that's really what's happening there. And if you remember this from last year, this is really just a right triangle now, right? So put your right angle in here. Because the x and y axis are perpendicular to one another. So we have the right angle there. Now, what theorem can I use to relate x, y, and r? Pythagorean. Good. Juliet, what would that say?
A squared plus b squared plus c squared.
Good. And in this terms?
X squared plus y squared equals b squared.
And that's the whole derivation for the equation of a circle. That's all it is. Because if I put this point anywhere else, if I put a point over here, say, and I put my radius extending from the center to that point, believe it or not, I still have a delta x. This would be my x now, and that would be my y now. That would be x, and that would be y. And it would still be x squared plus y squared equals r squared. It does not change. It does not change.
No, I get that notification too.
Restart. You're supposed to restart it when it says that.
Yeah, in the middle of your class, I'm going to start it.
Oh yeah, you're right.
Gotcha. I postpone it for 4 hours. So, again, what you're going to notice here, is the right angle is always going to be existent no matter where the point is. You're going to have this right angle here again. Because the x and y axis are perpendicular. That's the whole reason this works. So, the general form of a circle. Now, this is the form of a circle when it's centered where? Where's the center of the circle? At the origin, okay? At the origin. That's the key there. In a minute, we're going to go into an example where it's not centered at the origin, see what has to happen there. If it's not centered at the origin. Alright, let's go on to the first one now. 4 steps here in order to graph a circle. And we've done this last year, so this should be a repeat again. First, convert the equation to standard form if needed, and we'll explain that in a little bit. Because sometimes you're not going to be given in standard form. The first examples, we will. Then plot the center. Then plot 4 points. R units up, down, left, and right. What is R again?
Radius.
Radius. Good, radius. So put those 4 points there and draw the circle. And I'm going to add a little thing here. 1/4 at a time. Because some of you still have some pretty ugly circles on there, no offense. Sorry. Hey, I was looking at some notes and some stuff the other day, and some of the circles are pretty horrendous. Again, practice your circles, please.
Oh yeah, I draw a perfect one on the board right now.
Yeah.
You guys know how to draw a perfect circle. Come on.
No.
When you're standing up on the board, it's very easy. On the paper, it's harder. When it's on the board, use your arm as the radius.
I wasn't that guy that
You
was
stand next to the board like this, put your arm out. Okay?
You don't do that.
Take
You're
it.
like this.
Take it, move over here a little bit, and just go like this. And because your arm is the same length, no matter where, is it the circle going to be the same?
Looks like
You're using your arm as like a radius.
No, you say that now.
Do it on the board.
Go on board. Yeah.
Over there.
I don't want to erase on this
Yeah,
one.
you should just be science.
Yeah, we did that yesterday. Erase it anyway. She always puts her little.
So, this is what I teach always to calculus. You just stand next to the wall like this, and just take his arm and use it as a radius. Does that make sense?
That's it.
Starting here, going. Really? Really? That's not There was, Nani, that's what I'm saying. So I said, and Johnny even said, you can't even do it on the board. I said, on the board it's easy. In your notes it's hard. In your notes it's hard. What can you do though? Do you really need to, you want to draw a good circle? Yeah, you can just get a compass or trace something that's a
Is that how
circle.
they touch it? Your circles in Jersey?
Grab a shape that's circular and just trace it. Just trace it.
You try to do that comment. You try.
All right, let's take a look at the first one here. Oh, wait. That's not right. Okay. Now, before we get to the first one, what did we do in class when we had translations? Remember translations with H and K? What did they mean again?
A shift.
Go ahead. Because H was X minus H, right? And then plus K, so it was the same for K. So what we're going to do now is just simply start. Let's start with a very basic example here. If you had R squared, or let's say instead of R squared, let's say we had 28 equals X squared plus Y squared. And we just wanted to draw a quick sketch. Just a quick sketch. What would my radius of the circle be? In this equation, what would it be? Not 14, but I see why you say 14. Hold that off for a second. What is it? Of 28, not half of 28. You did divide it by 2, right? Remember, guys, the standard form is this. Right? Or backwards, it doesn't really matter. It's an equation. So the 28 is representing R squared, like this. So if you want to find R, you got to take the square root of whatever's over here. Make sure you don't divide by 2. Be careful there. So you take the square root of 28, which is approximately, 5.3, 5.2. What is it, 5.29 you said? Yeah. So about 5.3. So all you got to do is start at the center, go over 1, 2, 3, 4, 5, and then put a dot a little bit after that for 5.3. Go up. Put a dot a little bit after. Now, I was telling the other class the other day one thing that I didn't mention to you guys. The key point here is really having your axes set up correctly. Because if your increments are not consistent, it will not look like a circle. That's why a lot of the circles are messed up. Because people have really squished increments over here, and then they're like really spread out over here. So this part of the circle is going to be really long, this part is going to be short, and then it's going to look like an ellipse. Okay, so it's all about your increments here. And clearly mine aren't perfect at all, I can tell you that. Okay, this circle is going to be a little bit off, but it's all right. So I start at the top part, I'm going to do a quarter circle. Here's my quarter circle. I can continue on the left or on the right, doesn't matter. Do another quarter circle. Again, it's a little bit off, I know that. Finally, a quarter circle here, and a quarter circle down here. Okay, and the top is not that good, as you can see. The top's eccentricity is not great, but it's okay for now. So again, we're just sketching a circle that is centered at the origin. Right here? No. Yesterday, trying to get rid of it. 2 more
The old high school method.
Alright, now if we have an equation like this though instead. Why is this stretched out like this? There. I meant why is it not going back? So let's take a look at our first example now. What if we don't have something that says x squared and y squared anymore? Okay, we have to think back to last year, and last year we went over this. The standard form for a circle that is not centered at the origin is the following. And I'm not going to derive this one because we already did this last year. Okay, that's the standard form for a circle that is not centered at the origin. Okay, where it's centered at h comma k. So, use the standard form above to tell me what the center would be for this circle. What would the center be for the circle? 2 and negative 3. Don't forget the negative. Notice, this time it's x minus h, y minus k. So we use the opposite for both. So the center is 2, comma, negative 3. That's the center for the circle. Okay, that's the center. Again, because it's x minus h and y minus k, we know that we're going to do the opposite in the sense for both of them. What would the radius be for this circle? 4. Okay, why is it 4?
Square root of 16.
Good. Square root. Okay, the square root of 16. So can we sketch this graph now? Okay, it should be pretty straightforward. Again, as I mentioned, this is a bit of a review now, I know that. So draw my axes. Now, look at your center, please. Please look at your center. That's the part that's important. So what I should really do is this. What I should really do is draw a circle that has a more of a fourth quadrant section. Because my center is going to be over 2 and down 3, right? So really, I should draw an axis that looks like this now. Do we understand why I'm doing that? Think about where your center is. It's over 2 and down 3. Okay, over 2 and down 3. Now I should make my increments a little smaller so I can actually fit. Do you see what I do as I go through graphing? This is the stuff you guys need to be doing with a pencil so you can erase and fix your increments. Okay? I hope so, I do. But I feel like a lot of people still do, actually. So 2, 3. There's my center. What's the radius? 4. So what do I do with that?
Go 4 up.
Okay, so 4 up would be right here.
4
4 to the left, okay. 2 and 2, there's 4 to the left. 4 to the right. And finally,
4 down.
which is going to be off the graph. I'm going to move this down a little bit. Here's 1, 2, 3 units down, 4 units down. It'll be down here somewhere. Okay, let's extend my graph a little. Okay, so we've drawn 4 different points on the circle based on the length of the radius. Now what do?
Connect.
Just connect. Just connect.
Drawing a circle.
Quarter circle. Quarter circle. Quarter circle. Quarter circle. Okay? Just draw a quarter circle in all 4 spots again. Make it easier on yourself.
So my circles look like diamonds.
Yeah, mine's like a baseball field.
Yeah, you guys gotta work on the arc. Practice drawing like one arc at a time.
Are you gonna test on that?
How do you draw a circle? It's a multiple choice test, John.
At the end of the test, please draw a circle for
John, it's a multiple choice test. How could they test how you draw a circle?
I don't know.
I can see the halfway. Or bonus. Actually, bonus.
You should draw a circle on the grid. He said AC, not SC.
I said SCC.
He said AC.
I said SCC. I heard AC. I might have said AC.
Either way, yes, you can draw a circle still. All right, take a look at this one now. This looks very complicated at first. Okay, it looks complicated because of those coefficients that are there.
But don't those do nothing?
They do actually. They do something. We haven't had to deal with those coefficients before. Trayvon.
With the variable that represents 25 feet.
It'll be like A, yes, very good. It'll be like A. But I don't want to even have to deal with it. So what might I be able to do here? Yeah, everybody take a look. Everything has a 25, doesn't it? There's 125, doesn't that have a 25 also? So divide everything by 25, and you can do this. You can always do this. These cancel. What does this become? Just simply 5. Okay? Now, with that said, what's my radius?
5.
You all fell for it.
No, square root of 5.
Square root of 5. Remember, this is r squared right here, isn't it? This is r squared. And it's so tempting to say the radius is 5 because 5 is an integer. It's a nice number, right? You don't want us to take a square root of 5. So many people say, oh, it's just 5. Make it easy. This is r squared, okay? R squared. So the radius is radical 5. What's the center?
-1.
Again, opposite of this one, opposite of this one. Okay? Now, when you graph though, can you leave it as square root 5? Do you know how long that really is? So what should you really do? Round, please, round. Okay? 2.23. Check, please. Make sure you get the same thing. Okay, 2.23. So what am I going to round to? 2 1/4 maybe? Because I'm going to be graphing, right? So like round to like 2.25? Because that's an easy way to round to quarters. Now my center is at -1, 2. So what quadrant will I be in for the center?
Top left.
Yeah, the one right here. Good.
Right here.
What's its number?
Top left.
1.
Oh,
More than
1,
1.
2. Oh, 2. Man, I don't even know these numbers.
There's no way to someone choose like 2.
Okay. Second quadrant. So, you know why that works? You want to explain it?
Counterclockwise.
When you learn trig, when we get into trig toward the end, we're going to talk about something called a reference angle. And reference angles, the way they work is they work counterclockwise, starting at the positive x-axis, and it rotates this way. So it's in the order in which the reference angle rotates. We'll do more of that when we get to trig toward the end, but again, it's because the reference angle rotates this way, and it just goes in order. Okay? But again, it's nomenclature. If a long time ago somebody had decided, Descartes, for example, who came up with the Cartesian coordinate system, had decided to do it the other way, we would have chosen the other way. And for every day we'd be here 1, 2, 3, 4. But it doesn't matter really, as long as we are consistent among mathematicians, right? As long as there's consistency, that's what matters. Because if we do something completely different, and then another person does something different, we're going to get confused, right? But if we're all doing the same thing differently, it's like we're all doing the same thing. So if I switch the order 1, 2, 3, 4, but everybody in the world did the same thing, it'd be okay. Because we all be on the same page now, right? But if we start doing it in different orders, then we don't have consistency amongst our work. And that's why it's so annoying that we use the English system in America, and not the metric system, because there's no consistency. We have to convert everything. So we're the only country, including England, part of England, that still does use this. And Australia, actually. Sorry. Who complains about the metric system? No, I'm complaining about the English system. I'm complaining about the English system. I like the metric system.
So we can't just switch?
As a country, I wish we could, but people are stubborn. For a long time, people have been doing calculations in things like BTUs, or British thermal units, as opposed to joules, the standard metric unit for heat. Or, for example, instead of meters, everybody's been using feet, right? Wouldn't it be weird today to say, how tall are you, Miguel? Give me your height in meters. Do you know what it is, honestly? Meters, there's 3.1 feet in a meter. 3.1 feet in a meter. So you'd have to convert using conventional analysis every time. All I'm saying is that it's because it's been adopted that way, people haven't changed. I personally think it'd be easier just to change everything over to metric. So better base.
What's your width, Jason?
Now, let's go over 1 and up 2. Over 1 and up 2. Let's not have those comments, John. So, that's our center right there. Now, the radius is about 2 1/4. So what do? I go over 1, I go over 2, and then a little bit further. Okay? It's a little bit too far. I go up 1, I go up 2, and a little bit further. Over 1, over 2, a little further, finally down, 2, and a little bit further. Those are my 4 points on the outside of my circle, and now let's connect. Quarter circle. Quarter circle. Again, does it matter which one I do first? No. Quarter circle. Quarter circle. And again, what kind of lines am I using, guys? Dash. It makes it easier. It really does. Draw dashed lines for these. It really helps. And that one's even a little bit off. That's not a perfect circle at all. The center looks a little bit shifted to the left to me. Right? Bad day. All right. Now, what I want to do next is talk about our general form. Remember from yesterday, we said that if the discriminant was negative, it's either an ellipse or a circle. It's either an ellipse or a circle. We also said the other day that the values that were in front of these would be the same. So our standard form the other day was this. Remember that form from the other day? That was our general conic form. And we said that if it's an ellipse or a circle, the discriminant's negative. But we also said that. Well, no. A and B equal each other. A and C equal each other. What does B equal?
0.
B equals 0. B is equal to 0 in this problem. So really, what I know is this, guys. If B is equal to 0 for a circle, this portion is non-existent in a circle. Again, when something equals 0, it drops off, right? So since B is equal to 0 for a circle, that doesn't exist. So what people have done is simply this. They've started by looking at these two values as A and B, and then they call this C, D, and E. That's why it looks a little bit different. I really don't care about the coefficients right now. Okay? Just trying to show you why that is. Because you're going to see it this way in textbooks. You're going to see it looks like, oh, wait, yesterday this was a D in front of X, and now there's a C in front of X. There was an E in front of Y, but it doesn't matter. These are just dummy variables again. Okay, dummy variables just means they're placeholders. So, the reason you don't see a coefficient in front of X squared and Y squared is because A and B are equivalent, and what we're going to see is that A and B need to be actually 1 for a circle. Okay? We're going to have A and B equaling 1 every time for a circle. So that's going to be our general form. Now, the hard part is this. If you're given an equation like this, and you want to convert it back to this form, H and K, because it's easier to graph that way, it's not simple at all. That's what the difference is this year from last year. Last year, everything was given like this, right? And you just graph the circle like we just did here. But if you're given an equation in this form, how do you get it back to this form? And that's what we're going to do today. And this is going to incorporate the factoring that we learned yesterday. That's why we went to the factoring first before we did this today. Okay? So we're going to have to go from this into the x minus h, y minus k form. Okay, our standard circle form. So to do that, we're going to use this topic now called completing the square. Okay, called completing the square. Now, let me explain what I want you to really write down here. First, maybe the first sentence would be useful to write down. Okay? And what we're going to do is this. We're going to use this special case from yesterday. If you want to look back in your notes, we titled that special case. Okay? This was the square of sums.
One had the R plus something and then I think it was an R. It's A plus B and then A squared.
That was perfect cubes. That was difference of cubes and stuff. This is the square of sums. The square of sums. Or the square of differences. The square of differences. If this was a minus sign here, this would be a minus sign over here. Okay, so there should be a plus or minus. I gotta correct that in my notes. Now,
That's gonna be a negative.
plus or minus. Yeah, they're all plus or minuses. See this here, guys? Plus or minus, and this is plus or minus. Remember from yesterday, this was always plus no matter what we had. Okay, this was our example of a special case. So, in order to complete the square, there are several steps you can write down. Just write them down real quick, and we'll go over them with an example. It'll make it a lot easier. Okay, so just quickly write down your 4 steps. Make the coefficient of the highest power 1. Make the coefficient of the highest power equal to 1. Second step, move the constant term to the opposite side. This will make sense when we go through an example, it really will. Move the constant term to the opposite side. Remember yesterday how we did, and this is going to have to really think back. At one point in time I said, what was b over 2? We got a middle term, we took half of it, and then we squared it. Okay, we're going to use that again. We got c, very good, nice memory, people. So we're going to take half of the middle term, b, and then square it to get a c value. That's the third step we're going to do there, really. And the fourth step is to factor the perfect square trinomial. We're going to factor it so it goes from this part right here, we're going to factor something that looks like this into something that looks like that. Because take a look, ca plus or minus b squared on the right here, isn't that what the circle really looks like on each part? The circle is really what? X minus h, oops, not y, x minus h squared plus y minus k. Wow. Okay? That's what the circle really is. So we want to get these x minus h's or x plus h's, whatever they are, squared. So that's why we're taking this process under now. That's why we're taking a trinomial and converting it to a binomial that's squared. Okay? Let's go. Fast, people. Gotta write quicker.
We've only been had like
Typewriters.
You can use shorthand though. But I like you guys to write so that I can answer questions and make comments instead of writing. Because that's a waste of my time there, right? That's why sometimes I print you the guided notes. Today I was actually going to be honest, guys, but I was running a little bit behind. I wanted to get here early and print the guided notes. I didn't get a chance to.
And then you'd waste tree because it doesn't do frame back.
Well, it got fixed yesterday, even though your homework I copied earlier this week, so it's still single-sided. But it got fixed yesterday.
Why do you think about
We just don't sleep as teachers, you know that? We're all vampires. None of us sleep.
That explains a lot.
Wait, what?
That explains a lot.
What did you say?
She said, how do you have time to do all that stuff? I said, we just don't sleep. Just kidding. All right, let's look at an example now.
1 in the morning, he replied like 5 minutes.
Actually, I can't see I can see him replying many things. Not
I
that
sent
far.
him an email like 1:30 in the
Thanks, I
morning.
guess. All right.
I like replied in 5 minutes.
So, step one tells me, make the coefficient of the highest power 1. Look at the highest power, people. Where's the highest power?
X squared.
What's its coefficient?
1.
It's a 1, so do we have to do the first step?
No.
No, we don't. Second step, move the constant to the other side. So, start by moving it over, please. Take that constant term and just move it on over. Guys, up here. Now, remember, when you move something over, you're just simply switching the sign. That's all you're doing. You do not have to remember to subtract and add anymore because now you guys are smart enough. Just switch the sign. Personally, I understand why they teach you subtract 1, but just switch the sign and move it over. Now, the next step, take half of the b term and square it. What's half of 6? What's 3 squared? And then add that to both sides. Add this 9 to both sides, please. On the right-hand side, it's going to be 8. Yes, absolutely. So on the right-hand side, we're going to have an 8. But now, look at the left-hand side. That can be factored. What's the factors of that?
X plus 3, X plus 3.
Which it repeats itself, doesn't it? And that's what we want. We want to get something squared because we're looking at a circle. This is really, remember, x plus 3, x plus 3. And now what we've done here is created some quantity that is a binomial square, which is exactly what my circle is like. X minus h squared, y minus k squared. So completing the square, that's why it's called completing the square, gets you to take an equation and somehow change it. So I was thinking alternate or altercate. What's the word to change with alter? Altercate, is that a word?
Alternate.
No, alternate's like switching on. But alternate, make an altercation. Is that a change? There's a word that starts with A that means to change something.
Alternate.
I know, but alternate literally means to switch the position of two objects, right?
Listen to me, I know what I'm saying.
Make an alteration. There it is. Like when you hem your clothes, it's an alteration. Sorry. So, we need to make an alteration or a change to our equation here. So we changed it by moving over. I know, I apologize for my lack of vocabulary. You know why my vocabulary is not good?
Because you have to be reading.
When I was a kid, when I was younger, I did not read enough. It's the truth, guys. When I was in 11th grade, that's when I really started reading. I'm not joking at all. I read The Count of Monte Cristo when I was a junior, and I loved the book. And from that point on, I was like, wow, reading's actually pretty good. So, to be honest, I was very, what's the word? See, exactly, what's the word? My vocabulary was not good. I'm trying to find the word for it, and I can't find the word for it. Okay? Loquacious. I was not very loquacious. Loquacious means I didn't good vocabulary. Alright, now, let's take a look at this example.
Did you go to some kind of military communist elementary school or something?
Now,
No kind
No kind of for you.
focus. First, we need to have that coefficient to be 1 there, and I see it's a 2, right? Look at the coefficient in front of that square.
Divide everything by 2.
Good, divide everything by 2. Again, we want this to be a 1 in the front of it, so let's divide everything by 2. Even if these numbers weren't even, even if these numbers were not even, you still do it. Again, you still divide by whatever the leading coefficient is every time.
Do we have to write those little lines? Can we just write one?
You can just do it in your head, sure. Just do it like this, okay? If you want to start by just writing that down, that's fine. You can do one big line over 2. I think that's what you're asking, actually, right? Sorry. You can do it like that also, that's fine.
Then wouldn't you have to move,
But I want you to remember you have to divide them all.
wouldn't you have to move the p square over?
Okay, or we can just switch these two positions, right?
Yeah.
Same thing. I always keep the higher degree on the left. It's just something I've always done that way. Okay? So, if I want to get this in the right order, I need to switch these two. Switching two things on the equation means you have to switch their signs. So just move them around. Take the 4p, move it over. Take the positive 10, move it over. Again, subtract them from both sides. This is what I'm talking about. You don't need to remember subtract 10, subtract 4p. Just if you're switching their positions, just switch their signs. Next, what's half of 4? 2. What's 2 squared?
4.
So add 4 to both sides. Notice, I didn't care if it was a negative 4, because I'm going to square it anyway. And as Victoria said, there's no need to do this separately. You can roll the math in your head over here. You can just write this as a negative 6 to start. What does this become over here now?
P plus 2, p minus 2, p minus
Very good, Juliet. This is P minus 2, P minus 2. That's what that really is. And again, we have successfully completed the square. Okay? Technique down? Is that good? Now let's apply it to a circle, please. Let's apply this to a circle. It's easy, guys. Trust me, it's very easy. All right. So, let's take a look at our coefficients of x squared and y squared. Are they the same?
Yeah.
And they have to be for it to be a circle. If they're not, this will not work. It's an ellipse then. Okay? Are they 1?
Yeah.
So how do they do the first step? They could both be 2's, but then I have to divide everything by 2. Okay? Next, move your constant over. And watch what I'm going to do. Watch what I do here. X squared minus 4x blank, y squared minus 6y blank equals negative 8. Why am I leaving a blank there? What did we do last time?
Yeah. We left the square divide by 2 and then square.
And wouldn't it go like right here?
Yeah.
So I'm leaving blanks there now. Put a little plus sign here, maybe a plus sign here, and here. Because I have to take the value of b, which is negative 4, right? What's half of negative 4?
2.
Negative 2. 2 squared is? So I'm going to have to add 4 here, aren't I? So adding 4 there, you got to add 4 over here also. Next, look at the y part. What's half of negative 6?
3.
Square it.
9.
9. So I have to add 9, don't I? Add 9 here. And now look, you can factor this by itself and factor this by itself. And you'll be in the standard form of a circle. Okay? Very cool stuff the way this works.
Equals 5.
Again, the part on the left here, this portion, they're both boxes. The box on the left becomes x minus 2 quantity squared. This box on the right becomes x minus 3 quantity squared. Negative 8 and 4 is going to be negative 4. Negative 4 and 9 is positive 5. And take a look, isn't that the standard form of a circle? What's the center?
2, 3,
Radius?
5. No, square root of 5.
Thank you. Root 5, or 2.23, rounding to 2.25. I just want you to learn from that. Don't make the same mistake twice, please.
Come back next year,
So you get 4 like 9 by.
Guys, I cannot hear a question. Come on.
Wait, so you get 9 by finding the square root of 6?
No.
By having 6 and then squaring it. Half of this is 3, right?
Yeah.
Squaring it is 9. Half of this is 2. Squaring 2 is 4. Okay? Again, we're completing the square, but with regards to a circle. Let's do one more, and then we'll graph the last one also. I'm not going to graph this one right now. We're done that already.
So wouldn't that be negative 9 and a half?
When you square a negative, though, it becomes... That's why this is always going to be positive no matter what.
But we shifted over, wouldn't it have to be negative?
No, because... Oh, that's a good question. Here. What Derek is asking is this. Why are these negatives over here? What I'm doing is this, Derek. If I add 9 and 4 to the left side, I have to add 9 and 4 to the right side. I'm not shifting it over. I'm not moving it over, okay? I'm adding to both sides. Let's look at our last one here. I thought I had one with an example with a non-unit coefficient. That's annoying. Before you write this down, let's make believe these were 2's here, please. Let's put a 2 in each spot. Because I don't know why I didn't put a non-unit in fact. That doesn't make sense.
because you can do it.
So, be careful. If I don't want a 2 in front of those,
Divide by 2.
good. Divide everything by 2.
No, we don't.
Okay, divide everything by 2. Focus on this for now, guys. Next, move the 10 over, while at the same time reorganizing my equation. Group your x's. Group your y's. Okay, why am I grouping them in this order again?
So you can get the last factor.
Yeah, so I get the last term. To remind myself that I got to fill in those blanks. And again, over here, I'm going to fill in the blanks also, right? Whatever I put in those two spots there, whatever I put in this red spot is also going to go over here. Whatever I put in this green spot is also going to go over here. Now, I'm glad that I divided by 2, because a lot of the time, people get confused when it's a number that's going to become a decimal. It's the same thing. It doesn't change the problem at all. Okay, it does not change the problem one bit. So what's half of 2 over here? What's the square of 1?
1.
Square of 1 is 1. What's half of 5?
6.5.
Square that.
6.25.
Very good. What did he say?
You get a
Cookie?
Yeah.
Now, this is where it gets tough, and I'm glad we did this here. Yeah, sorry, I don't have cookies. So, we got, over here, what does this become?
X minus 1, X minus 1.
Very good, Juliet. Juliet, how are you doing these so fast? What are you doing?
You square half of the square root of that. And
Yeah, guys, take a look
The
here.
notes last night.
Just, the notes actually weren't on it last night, so she couldn't.
Oh.
Take half the middle term. Take half the middle term, guys, right? What's half of -2? It's -1, right? So what's half of 5 here?
2.5.
So this is just simply y plus 2.5 squared. Because it's very tough to know that without knowing the trick. And try this. If you FOILed this out, you would get y squared plus 2.5y plus 2.5y plus 6.25. And the 2.5y and 2.5y becomes 5y. Seriously, try FOILing it out if it doesn't make sense. That's how you always check that you're doing it right. On the right side, we got,
17.25.
wait, this is going to be 7.25 and -10. Please, guys, negative though. Negative here. Now, why would me changing this problem screw up our answer here? Remember I changed it up with the 2's in the front? Remember I put these 2's in the front here to change the problem to make it harder? What has that done to screw up our problem?
Made our radiuses.
Can a radius squared be negative?
No.
No. Okay? So when you have this on a test or your homework, you're not going to have to worry about that. That will always be positive here. Okay? So this is clearly not a circle. This shape would end up not being a circle. Yeah, you can't graph this as a circle. It's not. Okay? All right, so tonight what I'd like you guys to do, or this weekend I guess we'd say, first, you got a few examples of graphing, then a few examples of practicing completing the square, then completing the square and graphing. The numbering did not continue. For some reason, it got to 5 at the bottom of this page, then it went 6, 5, 6, 6, 6.
Whoa.
I don't know what. Sorry. I didn't even think about that. But anyway, the numbers are off. Obviously, don't worry about it. It's not a big deal. Two worksheets each. Two worksheets each.
I'm about to start, so
I don't know, Brandon. I don't know what you're doing. Second page. Second page. Second page. Pass it down. Karina, pass it down. Second page. Pass it down. Second page. Pass it down. You're coming back to the same seat. Second page. Oh, we don't have that.
Hey, did you call?
I did actually, yeah, I had a question for her last minute, but I think her phone was off. It's no big deal.
I forgot.